In this video, let's go ahead and practice converting fractions, decimals, and percents together. So for questions 1 through 4, we're going to be taking these fractions and writing them as decimals and percents. So for number 1, we have 7/8. I'm going to start by just doing some long division here. So let's take the 7. It's really 7/8 is really can be thought of as 7 divided by 8 as well. So we're going to put 7 inside as our dividend and 8 outside as our divisor. 8's not going to go into 7 a whole number of times. We can put a 0 up here. If we want to go ahead and keep going, though, we can add two decimals top and bottom of each other. So one in our quotient, one in our dividend, and add a 0 inside in our dividend as well. And then kind of keep going here. So pretend this 7.0 is 70. 8 times 8 is going to be 64. We're going to go ahead and subtract here and see that we're left with 6. We can go ahead and put another 0 inside this dividend and bring this down. 8 into 60 is going to go in 7 times without going over. That's 56. Our remainder here is going to be 4. We can go ahead and add a 0 and then bring this down. So 8 into 40, let's go 5. And that actually will be the end of our division here. So as a decimal, we can say that this 7/8 is going to be 875 thousandths. So that would be the decimal. Now, if you want to go ahead and take this decimal and then turn it into a percentage, what you're going to do here is, because percentages are per 100 or a ratio per 100, you're actually just going to take this decimal here and multiply it by 100. Then it's going to be a percentage. And so once we go ahead and do that, this is going to turn into 87.5% here. So this would be the percent version of this. And so we can say that the percentage here would be 87.5%. All right, let's check out number 2. For number 2, we have this fraction of 11/3. So notice how this is an improper fraction. Whenever you have an improper fraction, essentially we're going to know that we have a percentage greater than 100%. And we have a decimal that's going to be greater than 1 whole. So 3 goes into 11 3 whole times. 3 times 3 is going to be 9. We're going to be left with a remainder of 2. Now, when that's the case here, we can go ahead and add our decimals and add a 0 in our dividend. So 3 into 20, that's going to go in 6 times. 6 times 3 is going to be 18. You can see the remainder here is going to be 2. So this is going to just keep on repeating. So my recommendation here is just to stop down here. This is going to just keep repeating. And this is going to be the decimal of 3.6 repeater, or 3 6/10 repeater. So as a decimal, I'm going to take a pit stop there first and say it's going to be 3.6 repeater. And this would be our decimal. Now, if we're going to take this decimal and turn it into a percentage, we would take this 3 6/10% here, repeater, and then go ahead and multiply it by 100. Now, if you multiply it by 100, essentially we're going to move that decimal over twice to the right. Notice how there's going to be another 6 here, and there's going to be another 6, and so on and so forth. So there's infinite 6s. If that's the case here, keep in mind that this is going to be 366. These next two 6s aren't repeating, but the one after the decimal place is going to be repeating here. So that's going to be 366 6/10 repeater percent. We can go ahead and write it over here a little bit more clearly, 366 6/10 repeater percent. All right, let's try another one. For number 3, we have 3 2/5. What you can do right away, if you'd like to, because it's a mixed number, it's 3 so the whole number is 3. So as a decimal, we actually already know it's going to be 3 point something. If you wanted to turn it into an improper fraction, though, you totally could do that as well. But this would hopefully save you a little bit of time in the future. So you can just focus on this 2/5 part, which is 2 divided by 5. And so you're going to see that it's going to go in 0 times here. But you can go ahead and add a 0 inside. So 5 into 20, that's going to be 4. So that means 5 into 2 goes in 0.4 times. As you can see, we have a remainder here of 0. So at least for the 2/5 part, the 2/5 part is really the same thing as 4/10. So if you take that decimal and say it's going to be 3 4/10, that would be the decimal version. Now, if we go ahead and take this 3 4/10 and turn it into a percentage, we essentially are going to multiply it by 100 and put that percent sign on there. After this 4, though, as opposed to the one with the repeater, we just have a 0 here. So if we go ahead and multiply it by 100, we move it over 2 times to the right, that decimal place. This is going to be 340, and then put that percent sign on there as well. So we're going to basically say that 3 2/5, or 3 4/10, is also equivalent to 340%. All right, cool. We have one more here. we have 2 and 9/24. Something I'm noticing right away though is that this 9 and 24 are not simplified. So we should actually maybe take care of that first so we don't have to deal with as big numbers if we don't have to. So we can actually simplify this fraction to make it 2 and 3/8. So if you see that fractions can be simplified, totally do that and take care of that. So this is going to be 2 point something, right? Because it's 2 is the whole number. Now, what about the 3/8 part? Well, 3/8, let's go ahead and figure out what that is as a decimal. Okay, so 3 divided by 8, it's going to be 0 point something, right? So we'll put a 0 in here. That's going to be 3 times 8 is 24. The remainder here is going to be 6. Let's go ahead and add a 0 and bring it down. 8 into 60 goes in 7 times. It's going to be 56. We're off by 4. Let's go ahead and add one more 0. I think this should be it for our eighths. 8 into 40 is going to be 5 times. So 5 times 8 is 40. And we see here that we are having a remainder of 0. So the 3/8 portion of this decimal is going to be 375 thousandths. And so 2 and 375 thousandths is equivalent to that 2 and 9/24 that we started with. All right, next let's go ahead and take this 2 and 375 thousandths. Let's go ahead and convert it to a percentage. Let's go ahead and multiply this by 100. Again, percents are per 100, so let's go ahead and do that. It's going to be 237 and 5/10, but it's going to be a percent as we've moved the decimal twice to the right, and that percentage sign balances it out there. So we can say that this is going to be 237 and 5/10%. All right, cool. Now that we have practiced turning some fractions into decimals and percentages, let's go ahead and start with some decimals this time and then write some fractions and some percentages. Now I'm going to go ahead and start off by turning this decimal into a percent because I feel pretty comfortable doing that. So I'm going to just get that out of the way. Just like in the last example, let's go ahead and multiply this by 100 and then just put the percent sign on afterwards, right? So if we go ahead and do that, this is just going to end up being 65%. And there you have the percentage. It's that fast. Now, what about knowing this as a fraction? Well, when you read 65 hundredths as a decimal, then as a fraction, it's also 65 100ths, right? So you can go straight to a fraction like that. And then you can go ahead and see what can you divide these both by, what's their greatest common factor. I believe it's going to be 5 here, if I'm not mistaken. And if we go ahead and do that, 65 divided by 5 is going to be 13. And then 100 divided by 5 is going to be 20. So just be careful when you're dealing with the fractions to always simplify, but this would be as far as we could go. All right. For number 6, let's check this one out here. We have 8 thousandths is our original decimal here. So I'm going to go ahead and just write that down. We have 8 thousandths. If we want to turn this into a percentage, let's go ahead and multiply this by 100 and then put the percent sign on it. So if we go ahead and do that, this would be 0.8%. So yes, you can have a decimal inside of a percentage. It just means that it's less than 1% in this case. All right, so what about the fraction? Well, if you read the decimal correctly and say 8 thousandths, then you can go ahead and write the fraction pretty easily and say it's 8 over 1,000. Okay, now if we go ahead and simplify this, because you can, I think we can divide these. I believe their GCF is 4 if I'm not mistaken. If you divide by 4 and 4 top and bottom, I believe we're going to end up with 2 over, and I think it's going to be 250. So I believe this is as far as we can go. So this would be our simplified fraction. All right, next we have 2 and 625 thousandths. So I'm just going to go ahead and just copy this down first. So 2 and 625 thousandths. Getting the percentage again should be relatively straightforward. Let's just multiply it by 100 and put the percent sign on it. So if we do that, we're going to end up with 262 and 5/10%. So that would be our percentage. And then if we just wanted to go ahead and write the fraction, if we just read this properly, it would be 2 and 625 thousandths. So we can write it as a mixed number, 2 and 625 thousandths. So this would be already a fraction just like that. However, we also want to see if we can simplify here. So I believe, if I'm not mistaken here, we can divide these both by 125. I've just dealt with my eighths a lot, and so if you practice, it should get easier as well, and you'll memorize some of these. And so you're going to see this is going to be 2, and I believe this is going to be 5/8. Okay, so we can go ahead and just say this would be, I don't think you can simplify anymore, so I'll write it as a final answer, 2 and 5/8. All right, for this next one, we have a repeater, a little bit more interesting. So we have 45 hundredths, right? And that's going to be repeating. So 0.45, and that's going to be repeating. So if you want to turn this into percentage, the same process applies here. Let's multiply by 100 and then add the percent sign on. So if we do that, just keep in mind that the decimal is going to slide on over. So 45 is going to be the whole number. But don't just write 45%. After the decimal, don't forget that the 45 is going to keep on repeating. So we need to make sure that we write 45 and 45 repeater percent, right? So 45 and 45 hundredths repeater percent. So just be extra careful when you're dealing with anything that has a repetition in the decimals. Now, to get a fraction here, this is going to be a little bit more tricky to do. So let's go ahead and practice writing this out. So a great way to do this is to define a variable here. Let's say let x equal 0.45 repeater. Okay, so if that's true, we can write this equation down and say x is equal to 0.45 repeater. So this would be an equation, right? We've defined that x is equal to it. So just start there. Okay. Next, depending on how many numbers are repeating, we're going to multiply by that power of 10. So if there's one number repeating, we'll multiply by 10. If there's two digits repeating, we'll multiply by 100, and so on and so forth. Let's go ahead and multiply both sides here by 100 then, just because we see here that there's two digits repeating. If we go ahead and do that, you're going to see that we're going to get 100x on the left side, and on the right side, we're going to have 45.45 repeater on the right side. So if you multiply both sides by 100, it's kind of similar to the percentage, right? Now, what if for the next step, I'm going to write this one out more explicitly. What if we take away x from both sides? Like, let's go ahead and take away x from the left side and take away x from the right. But keep in mind that x is the same thing as this 0.45 repeater, right? We said earlier that x and 0.45, we defined them to be equivalent to each other. So we're allowed to take them away from both sides because they have the same value. So if you go ahead and do that, notice what's going to happen here. On the left side, we're going to get 99x. And on the right side, 45.45 repeater minus 0.45 repeater ends up just being 45, right? And this is a really cool way to kind of show that we can rewrite these repeaters as fractions, which then hopefully makes sense as you practice these more and more. But this is a really nice way to get these rational numbers to show up as a fraction. Now, finally, if we go ahead and just divide both sides by 99 here, you're going to see that this is going to turn into a pretty nice number here, relatively speaking. And so we're going to end up with 45 over 99. But then we can go ahead and I think divide these both by 9, right? So dividing these both by 9, we're going to end up with, let's see, I think that's just going to be 5 over 11. Now, if you'd like to go ahead and divide 5 by 11, do the long division and find out that it's 0.454545 repeater, feel free to go ahead and do so, but this would be the fraction version of this repeater decimal. All right, moving on, let's check out questions 9 through 12. Here we're going to be given a percentage, and then we're going to go ahead and write a fraction and a decimal. So starting off, I think going to decimals is going to be a little bit easier for me at least, so I'm just going to copy down this 36%. Now, if we knew from decimals to percentages, we would slide the decimal twice to the right and add a percentage sign. Then if we go backwards here, let's just get rid of the percentage sign and then divide this value by 100 and slide the decimal twice to the left here, right? It's going to go ahead and just go backwards in that process. So if we go ahead and do that, this decimal version is pretty straightforward. It's going to be 36 hundredths. So this would be our decimal. Now in terms of a fraction, keep in mind that percentages are all just ratios per 100, right? That's what it's out of. So we can just write 36% as 36 over 100 right from the start. And we can go ahead and simplify this using a GCF. So I believe here the GCF would be 4, if I'm not mistaken. If we go ahead and divide these by 4 and 4 top and bottom, I believe we would end up with 9 to 25 or 9 over 25. And I think these two numbers are relatively prime. So this is fully simplified. All right. For number 10, let's see here. We have 2 3/4%. So let's see. I think we could go to a decimal pretty well here. The 3/4 inside there. I think the better thing or easier thing rather to do is to go ahead and just turn that into a decimal from the start. And you may know this off the top of your head, but I'm just going to write it just in case. So 3, let's see, that's 30. 4 into 30 is going to be 7. That's going to be 28. And the remainder here is going to be a 2. Let's add another 0 and bring it down. So 4 into 20 is going to be 5 times. So that's going to be 20, and we have a remainder here of 0. So we know the 3/4 portion is the same thing as 0.75. So let's rewrite this as 2 75/100%. Right? We didn't really convert anything yet. We just rewrote the fraction part as a decimal. But if we want to go ahead and turn this percentage into a decimal, let's go ahead and divide it by 100 and slide that decimal twice to the left here. Right? So this is a pretty small percentage. And if we go ahead and rewrite this, I believe it's going to be 0.02. We have to add a 0 as a placeholder here. 0.275. So this would be the decimal. Hopefully this makes sense, because if you wanted to turn it into a percentage, you would slide it twice to the right, and it would be 2.75% or 2 75/100%. Now, a moment ago, we knew this as the percentage. So if you want to, for the fraction, you can literally just write 2.75. It's a percentage, right? So you can write it as per 100. But this is a little bit awkward since we have a decimal inside of a fraction. So typically what people are going to do here is they're just going to multiply top and bottom by 100. So on top, we're going to have 275, which is a whole number now. And on the bottom here, we're going to have 4 zeros. So that's really going to be 10,000. Next, I think we can go ahead and divide these by their GCF. I think 25 is going to do the trick here. Feel free to take a moment to go ahead and write out some prime factorizations or whatever you need to for that. But if we go ahead and do this, I believe this would be 11. 12 times 25 I know is 300, so it'd be 11 over, and I think this is 400. So if you had 11 out of 400, it would be 2 3/4%. All right, cool. So let's check out number 11. We have 65 8/10%. It's kind of nice it's already a decimal here, so let's go ahead and just rewrite this for a moment. It's going to be 65 8/10%. If we want to go ahead and make this a decimal, let's just go ahead and divide it by 100. Slide that decimal twice to the left here. If we go ahead and do that, the decimal is pretty quick. It's 0.658 or 658 thousandths. Now, if you want to save a little bit of time compared to the last example we just did, where I kind of wrote this percentage over 100 and then got rid of the decimals and everything, you could write this over 100 and then do the same thing by multiplying top and bottom by 10. Or if you can read this decimal properly, that should do the trick as well. So if you read this decimal, it's 658 thousandths. And so you can go straight to the fraction from here as well. So it's kind of a preference thing. See what works for you in the long run. All right, I do see that these are both even numbers, so we can divide them both by 2. If we go ahead and do that, I don't think we can simplify much more, but let's see afterwards. I think this is just going to be 329, which I don't think has any common factors with 500 here. So I believe this is as simplified as we can go. I'm just going to write 329 over 500. All right, cool. That would be our most simplified fraction. All right, for number 12, we have one final one here. This one is a percentage, but it also has this part that's a repeater, so it can be a little bit tricky here. So let's go ahead and give this a try. First things first, I'm just going to copy down the problem. So 120.3 repeater percent. Same idea. If we want to get this to be a decimal, let's go ahead and divide it by 100 and drop that percent sign. So if we go ahead and do that, we're just going to end up with, let's see, I think it's just going to be 1.203. And again, only the 3 is repeating, so make sure you have that repeater bar over the 3. And that's it. All right, now getting the fraction for this one is going to be a little bit tricky, but we did one earlier and we can try it again here, but this one's probably a little bit more involved. So, all right, so let's go ahead and define something here. Let's go ahead and say, let's let x equal this 1.203 repeater, right? So if that's true, we can set up this equation, say x is equal to 1.203 repeater. What are we going to do next after that? Let's go ahead and multiply both sides by 1,000 so we can at least get one of the 3's to not be a decimal over there. So let's multiply both sides by 1,000. If we go ahead and do that, we're going to 1,000x is going to be equal to 1,203.3 repeater here. Next, I'm going to do something a little bit strange. I'm going to go ahead and take away 100x from the left side. And basically, I'm just taking this x here and multiplying it by 100 to get 100x. So if I'm doing that on the left side, I should also multiply this by 100 and take it away as well on the right side. So it's going to be minus 120.3 repeater. So keep in mind that these two values are equivalent to each other because they're just 100 times larger than each of these values over here. And so subtracting 100x and this 120.3 repeater, which are the same value from both sides, we're going to get 900x on the left side. And on the right side, we're going to end up with this 1083. Okay, so feel free to go ahead and subtract those. Finally, we'll just go ahead and divide both sides by 900. This is basically just a one-step equation now. So if we go ahead and do that, we're going to see here that x is going to be equal to this 1083 over 900. Now, thinking about a GCF, you can divide these both by using divisibility rules. I'm thinking just 3 for now, at least. Maybe there's something more, but I think if you divide this by 3, that'll go nicely. I think we're going to get 361 over 300. All right, so as a final fraction here, we can just go ahead and say this would be 1 and 61 over 300. I think this fraction would be our final answer. All right, cool. So there you have 12 different problems, first with just looking at each of those different types. And let's go ahead and try an application problem together in question 13. So in 1970, women made up 8% of STEM workers and 38% of workers overall. By 2019, women in STEM occupations had tripled to 27%, and women made up about 48% of the workforce. These stats come from the US Census Bureau talking about the workforce in the United States. So for part A, it says write the percentage of women who were STEM workers in 1970 as a fraction and a decimal. So we have 8%. So 8% is what we're starting with here, and we want to turn that into a decimal. That's just going to be 0.08. And then as a fraction here, well, 8% is really just what? 8 over 100. So you go ahead if you want and then divide these both by 4. So we can go ahead and simplify these, right? And so we're going to end up with 2 and 25. So what can we take from this information here? So for part B, it says relating to ratios, explain what the fraction and the decimal represent in part A. So for the decimal, the 0.8 really represents that 8 out of 100 STEM workers in 1970 were women. Now what about that 2 over 25? The 2 to 25 ratio represents that 2 out of 25 STEM workers in 1970 were women. So while the values are equivalent to each other, they kind of show slightly different things based on the number that we are comparing it to. All right, let's check out part C here. In part C, it says write the percentage of women who were STEM workers in 2019 as a fraction and decimal. And then similarly, related to ratios, what does the fraction and decimal represent? All right, so in 2019, we know that the STEM occupation had tripled, more than tripled here. So we're looking at 27% of the STEM workforce were made up of women in 2019. So as a decimal, that's going to be 0 and 27 hundredths, or just 27 hundredths here. And as a fraction, we can go ahead and write this as just 27 over 100. And I don't think we can simplify this at all. 27 and 100 are relatively prime. And so the decimal here, the 0.27 or 27 hundredths represents that 27 per 100 STEM workers in 2019 were women. And we can say basically the same thing here, just because we couldn't simplify the fraction at all, that we would have the same ratio just expressed as a fraction instead. All right, so there you have 13 different practice problems on practicing converting between fractions, decimals, and percents, and kind of working with their different forms a little bit. If you found the video helpful in understanding this better, feel free to give the video a thumbs up and sharing it with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.